Hello everyone, in this video I'm going to show you how to machine aluminum with your Avid CNC router, or pretty much any CNC router if you get the settings and the feeds and speeds right. This video is going to primarily be focused on the aluminum frame that I made for my 3-pound beetleweight combat robot Psychotic Break. Here is the finished frame, which comprises of 2 pieces with some standoffs and stuff in between them. But the stock started out like this. This is 1/4 inch 6061 aluminum, and I think it's about 6 inches by 12 inch. It's a little bit oversized. But in this video, I just want to show you how to take a plate like this, mount it, do all the fixturing and everything, and end up with something like this. So let's get started. So the first step in any of this is figuring out the work holding and figuring out the fixturing. I'm over here at the CNC router, and you can see that I have a couple blocks of MDF just kind of attached to the table. For a spoil board for right now, I'm just using 3/4 inch MDF that is just screwed into the frame. That's all there is to it. I haven't even surfaced it down or anything like that. Still not 100% sure what I'm going to end up doing for a spoil board. This was just a piece of MDF that I got at Home Depot and just kind of screwed it down just so I could get going with this first project. For the actual aluminum frame, you can see that I have a piece of MDF over here that I just used a finish nailer, just boom, 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 boom. Just kind of attached it directly into the MDF bed. Really, really simple. In terms of getting this squared off, I typically use a bit or just kind of a rod or a shaft, something mounted into the spindle. And what I'll do, just this piece for an example, is I'll kind of lay it like this and then just run the spindle along like that and make sure it's touching the whole time. That will make sure that this is square to the axis of the spindle, and then, you know, sometimes I might go up this side. For a piece like this, it's not really critical because the fixture plate, once it's mounted down into the bed of the CNC, it's really not going anywhere. So generally speaking, I'll just take the spindle, run it across this front edge, make sure that that is parallel, and then nail it down. And that's really all there is to it. Now I use this top corner or this bottom corner over here for indication. So this is my 0, 0. And once I used the little probe that Avid CNC sells, I sat this in the corner, touched off of there with my Z, touched off there with the X and the Y, and I had this as my 0, 0, 0 coordinate, and then it was just a matter of drilling the hole pattern into the fixture plate. And that's really all there is to it for a simple fixture plate like this, is you need a known reference, which is my bottom corner here, and then I have the hole pattern, and once I have those 2 things, it's pretty easy from there. Unfortunately, I wish I had filmed more or any of the first part of this. I was just kind of going quickly, and I didn't really want the camera in the way and having to set up all the camera angles and everything. But this part was pretty simple, you know, pretty basic stuff. You're just nailing a piece of MDF to the MDF bed. From there, it gets a little bit tricky. So I have my piece of aluminum. I need to kind of set that on there and machine it in the pattern. So the first step that I did is I used carpet tape. This is carpet tape that you can get from Lowe's, Home Depot. I think this one specifically is from Lowe's. And I load up the back of my panel with carpet tape. And keep in mind, at this point, my reference is still this fixture plate at 0, 0, 0 right here in the corner. So I can put this on here, you know, like that, kind of over this way, over that way. As long as it's roughly covering where I'm cutting, it's fine. This doesn't need to be straight at this point because my reference is actually this piece, is actually the fixture plate. So what I did is I just used the carpet tape, put this down, you know, roughly lined up the edges and everything, and then I re-referenced my Z. So, you know, I used this guy once again. Now I'm referencing on the top of this plate, but not changing my X and my Y, or my X and my Y. So I'm not changing those, I'm just kind of lifting my reference up a little bit, and now I just simply re-drill that hole pattern. So now the hole pattern is just laid over top of it, and now I have a hole pattern on this that lines up perfectly with the hole pattern that's down there, and now I can just simply screw it down into the fixture plate, and now it is both held with the carpet tape, which is good but not perfect, and then also held with the screws, and at this point I can actually start doing some machining. But before we get to the actual footage of doing the thing that you came here to see it doing, let's talk really quick about drilling. Drilling is really not ideal with a machine like this because the spindle speed is so high and it's just not really configured for something like that. So drilling can be a bit of a trick, and I will definitely get into this later. I only drilled one of these on the machine. The other 3 that I made were drilled off the machine. So for drilling aluminum, the way that I found that works best is to use a peck drilling, which is a very short retract, and you're just kind of pecking down in. That is something you can easily find in Fusion 360, or if you like writing G-code by hand, you can certainly do that. It is just a simple can cycle that you can throw in there, and the little pecking actually works really well. The other thing that you can do for drilling is use a undersized drill bit and do a helical interpolation down, and that will actually use a smaller diameter and it will just kind of do a helical pattern. But I found that pecking actually works quite well for this, and that's how I did the drilling of the holes in the aluminum. So here's about the time that I decided to start filming. As you can see, everything is bolted down just as I said. It's taped on the underside and then screwed down into the fixture plate. In terms of feeds and speeds, I'm running about 15,000 RPM, about 60 inches per minute. I think about 0.025 inch step over, which is the width of cut, and then the depth of cut is the full 1/4 inch. I actually went like a little bit deeper, I think like 0.275 or something like that. Now this is using a 2-flute end mill. I did kind of change it up a little bit later, and I did change the feeds and speeds, and I'll mention that later. But these are all adaptive tool paths, so I'm only ever really doing a helical interpolation in the middle of something or cutting on the side. So I'm taking relatively small width of cuts, but a full depth of cut, and I'm moving relatively quickly. Now for these first cuts, I wasn't using any dust collection because you, the viewer, I wanted to have you see what was going on here, but it did make an insane mess in my shop, so for later shots I actually did end up using the dust collection. But as you can see, the cuts are really nice, the machine was moving pretty quick. I probably did adjust this a little bit faster in the actual Mach 4, but yeah, it just kind of gives you an idea what the very first cuts look like. So that was my very first pocket or my very first cut ever, and I did just one of these just to, kind of test the feeds and speeds and see if everything was working out. In terms of the cam, I'm not really going to go into too much details about it because this is actually a very straightforward part once you kind of break it down into pieces. But essentially what I did is I did these inside pieces. These were just simple adaptive clearing tool paths. So if you're familiar with Fusion 360 or HSM Express or HSM Works, the plugin for SolidWorks, you simply just select the lower edge and then it does an adaptive tool path. So I did these inside cuts here first, adaptive. Then I switched to the outside, and then once that was all done, I came back with a contour just to kind of finish those off. Contour on the inside, contour on the outside, and then it was just a matter of going through with a chamfer bit to chamfer everything. And that was pretty much all there was for the first side operation. Then it was flipped upside down, but we'll get to that later. So really pretty simple cam stuff. It's just a lot of pockets, but once you do the inside, do the outside, run a contour, then run the chamfer, it's pretty straightforward. So I realize at this point it might feel like I'm just kind of glossing over the details and just going very quickly through this whole process. Well, there's two reasons for that. The first reason is I didn't really film a whole lot of the first one because one, I really wasn't sure if it was going to work, and two, I needed to make sure that it did work so that I could use this as a process just so I didn't have to outsource it. So in the very first one, I was kind of more just stressed to see if everything would work, and I was kind of trying some different things out, so I really didn't film everything. But for the subsequent parts, what I did is once I got the first piece kind of made, and I made a lot of mistakes here and there and learned a lot through that process, Once I got the first one made, I used that as a template for all the others. The process of taping down the stock and then drilling it out and then screwing it in, all of that changed once I had that first piece made. So once I had the first piece made, I still used my carpet tape, but instead of taping it down to the jig, I taped that down to my next piece of stock. From there, it actually saved me quite a bit of time to just go over to the drill press, drill through all the existing holes, because I could just use a drill press and just boom, 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 bang those out, drill through all those critical holes, then take it off and bolt it directly down to the jig. The other thing that I did to save myself a little bit of time is I brought those blanks over to the bandsaw and actually cut off a lot of the bulk of the stock on the bandsaw, so that would mean a lot less wear on the end mill and a lot less chips. So basically the very first one was made from scratch, and it was kind of taped down and then screwed and all that other good stuff. But that was actually very time consuming to do for every single plate because there was a lot of setup involved. So for all the subsequent pieces, I literally just used that first one as a template and then, taped them together and did it that way. And that actually worked a lot quicker. So let's kind of go from that process, and I'll give you a little bit more detail on each one of the operations from there. So now that I have the blanks drilled and the rough size, or the, I guess the rough outline cut into them, the process can start. So really what you're seeing here is me indicating the X, Y, and Z 0 on the corner of the fixture plate. And I'm still using this same corner as before. And when I indicate off of this, then I can just simply place the plate on and screw it down, and I know that everything is lined up and indicated because I used this reference point to drill the holes that I'm drilling into. So I know that all these things are nice and consistent. Okay, now we're cooking with gas. So now it's time to actually start cutting some stuff. Now, you might notice a little bit of a difference in this. I am using a different end mill. I'm using a single flute, which, I'll get into that a little bit later, but generally speaking, the single flute just has less contact area, so I kind of like it for aluminum a little bit better. I found that the material wasn't getting nearly as hot when using the single flute as it was with the two flute end mill. Now, you might see that I'm cutting quite a bit of air here. I very easily could have modified my model in CAM and made it cut a different tool path, but honestly, I was just kind of lazy. I was doing some other stuff in the shop at this point, so I kind of had the time. I think this operation was maybe only like 10 minutes, so cutting it down would have only saved me a few minutes, so I just left it as is. It is not the right way to do it. It is the sloppy and the lazy way to do it, but it worked just fine, so it is cutting quite a bit of air, or not cutting anything. Feeds and speeds remained pretty much the same. I did bump everything up a little bit. I went up to a 20,000 RPM, 100 inches per minute, 0.035 width of cut, kept the depth of cut the same. So yeah, just kind of ran everything a little bit faster, and I'm running here without any kind of dust collection, just so you can see and hear what the cut sounds like. Throughout this video, I've been talking about adaptive tool paths, and I figured it'd be kind of a good idea just kind of give a very brief and simplistic overview about what an adaptive tool path is. So an adaptive tool path is one that tries to maintain a consistent cutting force and a consistent chip load. So every time that bit spins around and cuts into the aluminum or cuts into whatever material we're cutting, the adaptive tool path tries to keep a consistent chip load or a consistent amount of force on the bit. So when I say that I'm doing a 0.035 width of cut, what that really means is that it's always taking that much of a bite out of the material, and that is the step over, if you will. That is the amount of material that it's always taking on every pass. So when you see this operation going through, you notice that it's not really following the outline of the part as much as it is making sure that it takes the same amount of a cut every time. So it pays attention more to the amount of cut and the amount of force to take that cut than it does the actual outline of the part. So we're not just plunging down and slotting, we're doing an adaptive path that is actually taking a consistent amount of a cut every single time. So now that the outside is done, it's time to move on to the inside, and I'm not going to go into too much detail because we kind of already talked about this, but it was a good time to finally hook up the dust collector, hook up the dust collector shoe on everything and make it a lot cleaner. So you won't be actually seeing any more cuts at this point, but it'll kind of give you an idea what the cuts look like with a dust collector on it. Once the outside and inside was done, I switched over to the chamfer tool and decided to do all the chamfers. The chamfers are relatively deep. I think they're like 0.2 inch deep, something like that. They go almost all the way down. And I'm using a chamfer tool, which looks exactly like just a standard 2-flute end mill. It's just that it has a 45 or 90 degree point, however you want to look at it, at the end of it. And HSM Express, which is what I'm using as my cam for SolidWorks, doesn't have a good way of doing multiple depth on a chamfer, so I just kind of manually programmed them in with all the offsets, and I'm just doing this in 4 steps. So the first one just kind of takes off a little bit, the second one a little bit more, third one a little bit more, and the fourth one just kind of goes in and cleans everything up. It's the kind of sloppy way of doing it. I could have exported this over to Fusion 360, which has all those operations in there, and I could have just clicked a couple buttons and had it all done, but I didn't want to export this and import it back, so I just kind of manually programmed this all into SolidWorks. Okay, I actually did forget one little piece. There are counter bores on all of the screws that hold this down to the plate, or the fixture plate, and this was a really simple process. All I did is do one at a time. I just took out the screw, ran the counter bore operation for that specific screw, put the screw back, and then moved on to the next one. So yeah, it's one of those things that you could really get overcomplicated with this because these are the mounting holes, but really all you have to do is just do one at a time, remove the screw, do the counter bore, put the screw back, boom, you're done. So nice and easy. So now that all the top side operations are done, it's just time to flip it over and do everything on the bottom side. Now, I was asked a few times by a few different people how I indicated the bottom side and how I flipped it over and all that good stuff. Well, the short answer is I literally just undid the screws, flipped it over, screwed it back, and just hit go again. So the thing is that all the critical locations and all the critical holes and everything is all done on the top. There's nothing critical on the underneath side. I just have these slots or channels or whatever you want to call them for weight savings, and they're just roughly centered on the mass of, what's left of this part. So as long as they're, kind of roughly on there, that's good enough. Granted, I do run a chamfer along the whole bottom side, and if that's off, by let's say 1/10 of an inch or something, it'll look really funky. But generally speaking, this just has to be mostly lined up. It doesn't have to be perfect because there's not really a seam between the top and bottom. So all I did is use the existing mounting screws, undid those, flipped the part upside down, and then just reattach the screws. Now, I am using countersink screws everywhere, so they kind of want to self-align a little bit. There's very little play once you kind of tighten everything down, but that's really all there is to it. I did also go a little bit deep on all the contours, so I am cutting into the MDF. You saw that earlier. You could kind of see the outline of the part on the MDF. So I just kind of looked at it and make sure everything looked like it was lined up. But generally, if it looked like it was lined up, the operation was going to be fine. So yeah, There was no magic, there was no dowel pins, there was no indication whatsoever. I kept all the origin the exact same, undid the screws, flipped it over, ran the operation, and that was that. Nice and simple. And here is what the finished part looks like. Overall, I think it turned out very nice. So there is a little bit of finishing on this part. Basically what I did is I have one of these that I can mount into my drill press, so I kind of use that for the outside edges just to take off a little bit of the chatter that I got on the chamfer mill. And then the rest of it was just kind of a sanding block, and then one of these red Scotch-Brite pads just to kind of buff it out a little bit. And then I think on this one too, I did a buffing wheel on the drill press. And it just, you know, kind of has a nice simple satin sheen to it. Nothing really too fancy. I probably could have done a poly coat on this, but that's just a bit much. Yeah, overall, everything was good. I had no issues with these parts. Everything was nice and accurate. Everything was nice and lined up. So I made this video kind of for myself, I guess, in a way. When I was looking to buy the CNC router, I was trying to find people that were doing something similar to this, not just cutting out 2D shape, but someone that was doing something a little bit more complicated like this. And I think I've shown in this video that you can definitely use a CNC router in many of the same ways as a standard vertical milling machine, as long as you pay attention to feeds and speeds. But the overall outcome of this I am very happy with, and I will definitely be using this machine for more aluminum projects to come. I think having this CNC router is going to open up some new possibilities for me. I still have my Tormach, I still use it. I use it extensively actually throughout this project, but for these larger scale parts, I think the CNC router is going to help me tremendously. And once I kind of learned how to dial in the feeds and speeds and get everything, you know, working the right way, I was actually able to push it a little bit further. I was up towards 120 or 150 inches per minute towards the end on the fourth and final part that I did. And I think, you know, once I start getting everything dialed in even further, I think I'm going to find that perfect sweet spot. Now, the thing that I never mentioned anywhere throughout this video is I was running completely dry. I have no coolant. I have no kind of lubrication, nothing like that. I'm running completely dry. That is something I plan on changing. It was just way too much to do all at once. I had a very small window where I needed to get these parts done. And in that window was buying the machine, assembling the machine, and setting it up. So I really couldn't add too much complexity to this project. But eventually I do plan on doing some sort of mist, coolant, something like that. I don't know if it's going to be alcohol. I don't know what that's going to look like. But in any event, I will plan on addressing that later. I'll talk about the dust collection and all that stuff at some other time. But this was just kind of a test to see what the machine could do with aluminum and whether it could cut the way I wanted it to, and I think that was a success. So be sure to be on the lookout for more videos coming up. You can follow my Facebook page for any kind of updates like that. Check out the links below, and I'll see you next time with even more videos. Thanks for watching.